In this video we're going to look at the intermediate value theorem. It's a very fancy name for something that's actually very simple. Basically, if you have a polynomial function and when you do p of a you have a negative number, and when you do p of b you have a positive number, here that corresponds to below the x-axis and above the x-axis, then at some stage the function has to, if it's going to get from a to b, it's going to have to go through the x-axis. In other words, there's some value of c that when you do p of c, it gives you 0. Right? So somewhere between a and b, there must be some place that it crosses the x-axis, and that place is c. And that's all that this statement here says. If you have a polynomial and a and b are two real numbers, and these two things, the y coordinates, have opposite signs, one's positive and one's negative, then there's at least one number c between a and b such that p of c, the y coordinate, is equal to 0. Now, this example is actually something that we don't have to do too much these days because we have graphing calculators that help us to find out where things cross the x-axis. If you're interested, you can get it by using, on the TI-84, the second calc 0 function on your calculator. So you go to second, you press calc, and then it's the function 0. You go to the left of the crossing point, you go to the right of the crossing point, and press enter, and it should give you the x-coordinate and the y-coordinate, which will be 0 of this point. In example 4, we do things in a different way, right? The old-fashioned way. What we do is we use some trial and error. We just take random values of x. Here we've taken a random value of x equal to 1, and we've got p of x equal to 6, that's a positive value. And just randomly, if we choose x equal to 2, p of 2 is another positive number, so there's nothing interesting there. But if we try p of 3, plug in 3 in here and here, that gives us a negative y value, so p of 3 is a negative value. That means that between 2 and 3, the function has gone from positive to negative. So there must be what we call a 0 between 2 and 3. It must go through the x-axis somewhere between 2 and 3, this function. So, where would that happen? Well, we try some more trial and error. We try 2.1. When we plug 2.1 into this expression, we get a positive number. We try another number, 2.2. Well, that gives us a negative number. So we know now that it's going to cross the x-axis somewhere between 2.1 and 2.2 because these numbers are a different sign, positive and negative. Now, it asks us in this question to round to one decimal place. So do we round to 2.1 or round to 2.2? What we do to decide is we try a number halfway between 2.1 and 2.2. We try 2.15. And if we try 2.15, 2.15 gives us a positive value. Now 2.15 gave us a positive value, 2.2 gave us a negative value. So our answer must be between 2.15 and 2.2. So our answer is closer to 2.2 than it is to 2.1 because it's between 2.15 and 2.2. So we would round our answer to 2.2. And that's just what is said down here. Since we know that our number is between 2.15 and 2.2, we round it to 2.2.